Okay, welcome back. Today we're going to talk about solving an equation for a given variable. All right. Now let's say that I've been given this equation right here. So right now, this equation as it sits, ay is equal to b, this is solved for b. And I know that because b is isolated. Okay, I could rewrite this as b is equal to a times y. So right now, it doesn't really matter. These are equivalent equations, right? By the way, that's called a reflexive property. If I say that reflexive property says if A equals B, then B equals A. It's reflexive about it can be switched around the equal sign. Okay. But anyhow, right now it's solved for B. So a question that arises, or sometimes you might be interested in solving the equation for another variable. So for instance, let's say we want to solve it for Y. Well, when we solve it for Y, I want to pretend like first of all, my goal is to get y by itself. I want to get y isolated. So it doesn't matter what sort of mess happens on the other side, as long as y is by itself and everything else is on the other side of the equation. It doesn't matter if y is on the left-hand side, if it's on the right-hand side, but as long as y is by itself and everything else is on the other side, then I've solved it for y. So here, I have a on the side. A is attached to y with multiplication, so I'm going to divide each side by a. Okay, so I have y is equal to b over a, and that's it. Okay, y is left by itself. I have some expression on the right-hand side that doesn't involve y, and so that's all I need to do. Okay, so I've solved this equation for y. Let's try another one. Let's solve it for x in this situation. So x, there's two things attached to x. We have a that's attached by multiplication and b that's attached by addition. Okay, so the first thing I'm going to get rid of is b. So I'm going to subtract b from both sides. We have ax is equal to 4 minus b. Now 4 and b are not like terms, so I can't actually combine them. All right. So I'm just going to leave them just like this. A is attached with multiplication, so I'm going to divide each side by a. And so I have x is equal to 4 minus b all over a. All right. Now there's nothing that I can actually do here. I can't actually subtract. I can't actually divide by a. But it's the whole goal of this lesson is to isolate a. So it's sort of like a trick. Like here I've just isolated a. There's a bunch of junk on the right hand side, or just an expression that's a little complicated on the right hand side, but that's perfectly fine because the goal was to get x by itself. Okay, so I want to solve for x in the following equation here. Now, notice it's a little bit more complicated because I have x in two terms. So always think about where is my x located. So here my x is in two terms. So here's the trick. Get all the terms with the x on it, with the x in them, rather, to one side. Okay? So here I want to get this 2bx to one side. So here I want to add 2bx to both sides. Okay, so I have 4bx plus 2bx is equal to 6b squared. So notice I have all the terms with the x on the left-hand side, and I have the terms without the x on the right-hand side. Okay. Now what I would like to do is factor out the x from these two terms. Okay. Oh, actually, those are just like terms. I can just go ahead and add those together. Not a big deal. 4bx and 2bx are like terms because both of them are raised to the first power. So I would have 6bx. That's a little bit easier. Okay. Well, if this is the situation, then 6b in this situation, we want to get x by itself. 6b is being attached to x with multiplication, so I'm going to divide each side by 6b. So I have x is equal to, well, 6 divided by 6 is just 1. B squared divided by b is just b. So I've simplified this equation a little bit. Just because of the way that it turned out. It doesn't necessarily make it more simple if you're solving for a variable, but in our case it did. So we have x is equal to b. That's it. Okay. Okay, if I had to solve for y in this case, so this is the term with y and these are the terms without y. So I'm going to try to maneuver this minus 3m squared to the other side. So I'm going to add 3m squared to both sides. Fortunately, as it turns out, these two things are like terms. So I have m squared y is equal to 20m squared. Okay. Now I want to divide each side by m squared because I want to isolate y. So I have y is equal to just 20. Okay, and I have solved it for y because y is by itself and there's something else on the other side. Okay, let's actually work with a formula here and let's solve a formula for a particular variable. This is something that is of interest. So solve the formula d is equal to rt for t. Okay, so in this case, I'm going to take this formula. Right now it's solved for d. Distance is equal to rate times time. All right, a formula is an equation where the variables all mean something. All right, so here I'm solving distance is equal to the rate times the time, and I want to solve it for t. So in this case, to get t by itself, I want to divide each side by r. So t is equal to d over r. And so another way I could write this is t is equal to d divided by r. It doesn't matter, but they're both solved for t. But sometimes I like to have my isolated variable on my left-hand side. Okay, so I've done the first part. I've solved it for t. Use the answer obtained in part A to find the value of t when the distance is 200 and the rate is 40 miles per hour. That's actually should be the r is equal to a rate, so you got to be careful here. What I'm looking for is the time traveled. Okay, so time traveled is equal to 200 miles. Whoops. Divided by 40 miles per hour. Well, here, if I divide each the top and bottom by 10, it gets rid of those. There should be 20 over 4, and 20 over 4 is just 5. So our units here, if it were the rate were in miles per hour, the unit would be in hours. Okay, so our time is equal to 5 hours. So if you traveled 200 miles at a rate of 40 miles per hour, you would have been traveling for 5 hours. Okay, let's try our hand at another formula here. So if the volume of a cone is equal to the volume, so a cone in this situation would be a circular base with a pointed area at the end. So the volume of any cone is the area of the base times the height of the cone. So the area of the base in this situation, our base if it's a cone with a circular bottom right here, then our base is a circle. So our area is going to be 1/2. It's going to be a pi r squared. Sorry. So it's going to be pi r squared. And you know what? I actually don't need to do that in the first part here. The volume of a cone is equal to V equals 1/2 this uppercase B times the height of the cone. So I want to solve it for H. So in order to do that, let's think about this. I have this fraction in the front. Another way to write this, by the way, is capital B times H all over 3. Okay, 1/3 is the same thing as putting this BH over 1 and then actually finding the product for the numerators and product for the denominators. So in order to get rid of that 1/3 or that divided by 3, I'm going to multiply each side by 3. So I have 3V is equal to capital B times H. Okay, and if I'm solving for H, I'm going to divide each side by capital B. Okay, so 3V over capital B is equal to the height. All right, so I've solved this formula in terms of H. Now the formula happens to be the volume of a cone. All right, so find the height of the cone that has a volume of 92.0 cubic centimeters. Volume is always in cubic units, and has a circular base with a radius of 2.8 centimeters. Okay, so the height is going to be equal to 3 times the volume, which is 92, all over. Okay, the base area here is pi r squared, so it's pi times 2.8 squared. So that's going to be in the denominator here. So it's pi times 2.8 quantity squared. I'm going to pull out my calculator for this. So we have 3 times 92. Actually, let's put it all in as a fraction. So alpha y equals here. Then we have 3 times 92. And we are dividing that by pi, which is second and caret, right? That gets me the pi, times 2.8, and that's squared, okay? So here's my answer, 11.2 11.21, and the height is going to be in centimeters. So it's going to be 11.21 centimeters. Okay, and that's the end of the lesson for today. So we talked about solving equations for other variables, and we also talked about solving formula for specific variables, and then using our solved formula and inputting values in. All right, and that's it.